I would love to have some time to review for the exam, those of you that are going to take the exam. And our days are numbered. All right, so in your packet, there are 3 pages, and I want to do problem 3. Let's do problem 3. Your test will have one of these problems on it, okay? So we gotta get ready, we'll be able to do it. So problem 3, here we go. We are in the little packet I gave you of linear programming problems. We're doing problem 3. Now, don't be confused. I will have a chart set up for you on the test, but I won't have anything written in it. So this one, they already wrote in x and y, x plus y, and that should make sense to you because the question is, and it's clear at the bottom, but it says find out how many of each kind of pizza you should make. So that's your x and your y. What number of these should I make? What number of these should I make? And then the total number of pizzas I make is going to be x plus y, right? Those added together. So again, I'll have these things set up for labeled, but nothing inside. You're going to have to put all your own inside stuff. But this should make sense to you, even though they've already filled that in. All right, so what about the rest of it? It costs $10 for Geno's to produce a deep dish pizza, and they spend $2 for deep dish and packaging. So to make a deep dish costs $10, and to package it costs $2. It costs them $7.50 to do a thin, and they spend $1 in packaging. Are we following along, everyone? Yes. We only have $145 to make pizzas, and we only have $24 to spend on packaging. We make $20 on a deep dish and $15 on a thin crust. So far, so good. We are trying to, well, the question is clear down at the bottom. I don't like the way this is formatted, but the question is clear down at the bottom. Find the number of deep dish pizza and thin crust that I need to make to maximize my profit. So what will be my profit expression? They're calling that the objective quantity representing profit. What's that going to be? Profit will be 20x plus 15y. That is not what I graph. I do not graph that. What is that used for? At the end, when I have all my picture drawn and I have my points, that's where my points go, right? And since I want to maximize, I'll be looking for the biggest answer I get. All right, now what are my constraints? These are the things I'm going to graph.
10x plus 7.5y
is less than or equal to 145. Now, why is it less than or equal to? Because sometimes it's greater than. Why is it less than? I only have $145. So whatever I spend has to be less than or equal to 145. Does that make sense to you? All right. Now, what's my next constraint?
2x plus y less than 4.
Yep. two x plus y is less than or equal to 24. And then, of course, I'm gonna go ahead and include that x and y have to both be positive. That's gonna be part, I wanna say always, but there's probably an exception. When we're doing these problems, we can't have negative pizzas. So x and y are almost 99.999% of the time, they're gonna be positive. All right, so now we're ready to graph. Thinking about these equations, this one doesn't have any decimals in it, the numbers are littler. But if I let x be 0, y is gonna have to be 24. So I might wanna consider, I'm not gonna do that on test day, you're gonna have to figure your own scale, but we're using a scale of 2, does that kind of make sense? So that when I graph this one right here, if y is 24, I don't have to count all the way to 24, I'm only going up to 12. And then x is 12. Did I lose anybody in there? Is everybody okay with that? Using a scale of 2 to accommodate the picture?
What did you just hold up?
Get what, 12? If I cover up y, x is 12. And where will that one be shaded? Here, not to the right, it's less than, it's less than. So we're shaded in the triangular area. Here we go, if I cover up y, x is gonna be 14.5. Here's my x. And if I cover up x, I don't know what that is. 145 divided by 7.5, about 19.3, is that what you said? Someone said something. So, and where's that one shaded? Also under? So the area that I have outlined, I'm under pink and under blue. So that would be from this point down to this point, over to this point, up to this point, and then to here. Does that black section look like what is under pink and blue? Is that okay? So what are my points? Well, what do X and Y stand for? The number of pizzas this place is gonna make. So this point isn't going to be 0, 19.3. This point is gonna have to be 0, 19, because Gino's is not gonna make 0.3 of a pizza. Right, use your common sense. All right, we got 0, 0. We've got 12, 0. And then we've got this guy. How do we find that? We can eyeball it and maybe be wrong, probably be wrong. Or we can do it algebraically, and who remembers how we do that? We're trying to find where these two intersect. Well,
Or
yeah,
you'd
we
like to
substitute or eliminate. And you know what I'm gonna do, because I always do it? So I'm gonna multiply this equation right here by -5. -5, so that my x's cancel. Oh, I think that works out, doesn't it?
Yeah.
Isn't it 10?
Yeah.
So y is 10. And if y is 10, x is 7.
Yeah.
So maybe you could have eyeballed that, I don't know. I couldn't, for sure. Okay? Now, my answer is gonna come from one of those. Remember, this process finds your maximum and your minimum. Obviously, this is my minimum, because if I don't make any pizzas, I don't make any profit, right? But what if I did 7 and 10? 7 and 10. If I did 7 and 10, I'd make $290. If I just made 19 thin crust, I'd make $285. Are you seeing where these numbers are coming from? 0, and then if I make 12 deep dish, I get $240. Maximum profit occurs at what point? So this guy should make 7 deep dish and 10 thin crust for a profit of $290. Just wanted to do it extra good. Of course, if you practice some others and want to bring them into office hours, that's totally fine. Right now, I want you to get your review packet out and turn to page 6. Page 6 is pretest number 1. So page 6 of the review, pretest number 1. Now, this is, as you can tell, an old review sheet. So things have changed a little bit, not the math, but the requirements of the course have changed a little bit. So you will have, just like you had a calculator problem on the quiz you just took, you will have a calculator problem on your test. All right, you will not be doing Gaussian elimination. We haven't done that. You'll be using Gauss-Jordan reduction, which is the RREF button. Okay, so nothing's going to be different. You're going to do the calculator problem just the same way you did on the quiz, okay? So you can cross off those directions if you want. And let's do number 1. Using the normal procedure, which is, the formal name of it is Gauss-Jordan reduction, but that means we're going to use our reduced or echelon form. So here we go. Problem number 1 on page 6, which is pretest number 1. Hopefully this went well on your quiz. What are my dimensions? 3 by 4. get so annoyed, Michael, when you just sit there. Honey, look along with us. We're practicing for you. And everyone. Oh my goodness. Tell me I typed a number wrong.
That's what I got.
Why am I saying,
This is all zeros on the back.
And when there's all zeros on the bottom, what are my variables, X, Y, and Z? When there's all variables on the bottom, that means I'm going to have infinitely many solutions. I'm not gonna be able to say, a normal answer would look like this. And I'm not gonna be able to do that because the bottom row says, literally says, 0z equals 0. Which means Z can be anything. And then X and Y will be defined in terms of Z. So 1 plus 2Z is 1.4. So, one Y, sorry, 1Y. Y plus 2Z is 1.4. So 1.4 minus 2Z is Y. 1Y plus 2Z equals 1.4. And then 1X minus Z equals 1.2. So X equals 1.2 plus Z. Does that look good? So then I'll write my answer. Noticing that each variable, like X for instance, X has a number and a Z. So X's number is 1.2 and his Z is what? And Y's number is 1.4 and his Z is -2. What is Z's number? No. He's got one Z, but his number is 0. This is 0 plus Z. Wow. That's a bummer. All right, let's do the next one. Anybody, I'm gonna have to erase it all. Anybody have a question about any of that? And what caused all of this? What is a red flag? That right there, right? That's when you have to do all this. One more. Try not to get bored. You need to probably do this on a different sheet of paper. I did not leave room for it. All right. Hopefully this doesn't happen. you get 1, 2, 3 as your answer? Anybody?
Yeah.
Everybody okay? All right, now we got all these operations to do. A plus 2B. First of all, can we even do it? Yep, because A and B have the same dimensions. So we're gonna have our A. And then to get 2B, we just take 2 times all the numbers. So negative 2, 10, 12, and 14. And then we add them. So negative 1, 9, 14, and 17. Everybody okay? We don't want to lose points on those kinds of problems. Are we good there?
Is that just the answer?
That's the answer. Okay, plus 2B. Problem B. What are we doing in problem B? Finding the inverse. Who remembers our process for finding the inverse? First we find the determinant. So the determinant will be negative 7 minus 30, so negative 37. And then we make our new matrix by flipping these. Notice I'm not changing them, I'm just moving them. And then these two become negative. Yep. No.
Then we just simply divide.
Then we just take all of these numbers and put them over negative 37. And then reduce anything that reduces. So we don't need to do anything but worry about the negatives. So 7 over negative 37, 5 over 37, 6 over 37, and 1 over 37. And there is your inverse. All right, Jimmy, you remember those steps?
Yep.
Anybody have a question there, Alden?
Why is the final answer negative 6 over negative 37?
This is the final answer. So those negatives cancel. This is the final answer right here. All right, another inverse. What about problem C? Jackson is shaking his head. You can't do it because the matrix isn't square. And if it's not square, you can't do the determinant, and therefore you can't do the inverse. Right? So C is a can't do. Can we do the determinant of A?
Yes, we can.
What is the determinant of A? Five, 3 minus negative 2. Okay. How about the determinant of C?
No.
Already talked about it.
Nothing.
You cannot do problem E. C is not square and therefore has no determinant. What about D? Can we do the determinant of D? Yes, we can. So again, you have to remember the process. It's easy. You just gotta remember what to do. Who can remember how we find the determinant of that voice.
You go 1, -1, 1. And
So
then
he says recopy
Like,
that
recopy.
column right there
2, 1, 0.
and the next one. So these two columns are getting recopied right here. Okay? Now what? We start right here and we multiply. So that gives me 2. I'm multiplying. And I multiply and that gives me 8. And then I multiply and that gives me 0. So all of those, boom, 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 total up to 10. Then I go the other direction, same thing. So 3, 0, -4. So those total up to -1. And then what do I do with those two numbers? Subtract. So the answer is 11. Can I multiply? G is a multiply. Can I multiply A and B? Yes, because with multiplication, they don't necessarily have to have the same dimensions. They don't have to be square. What is the rule for multiplying?
The middle two.
The middle 2, and then the outside 2 tell the
And
dimensions.
the outside two tell us that our answer will be a 2 by 2. Alright, so let's just stop and make sure we're all straight on that. When we multiply, the matrices can be any size. They don't have to be square, they can be anything. But when you write them down, these two dimensions have to be the same. So a 5 by 2 and a 5 by 2 do not multiply. But a 5 by 2 and a 2 by 3 do multiply. And in this case, the answer would be a 5 by 3. Okay? So, we can multiply these, and we're gonna end up with another 2 by 2. When we multiply, it's row times column. RC, always rows first. We're gonna do the row first. So row times column. So my row is 1, -1. My column is -1, 6. Multiply each pair, add them up. I got -7. Did you?
Yeah.
Everybody kind of remembering this? Then I'm gonna move over here, and I'm gonna do row 1, but now column 2. So same row, but now this column. So that's gonna give me -2. Now row 2. So 2, 3, -1, 6. What is that, 16? And then row 2, column 2. 41. And there's your product. The next problem says C times D. Can we multiply matrix C times matrix D? We absolutely can, because this guy is a 2 by 3, and this guy is a 3 by 3. So we multiply. And what will my answer be? My answer will be a 2 by 3. All right, we got a few minutes, let's fill them in. You do it. Fill them in.
It's the first and last number. Is that right? 2 by 4?
Get ignored, boy. Negative 2.
Maybe use your gamer tag.
What about Michael?
Address by gamer tag.
Negative 2 to 0.
Where do people watch the ticket?
Negative 3, 8, 5, 7, 3, 0, 4, 7 again. 6, 0, 6, 9, 0, 8, 17. My mental math is point
Guys,
Yeah.
this,
You could write it 1 minute
today. It's all stored in my head.
Yeah.
anybody got the top row?
Negative 0, or negative 2.
Negative what?
What's a negative 0?
Negative 2? Just stop.
0 and 8.
What's 6 plus 5? Yeah.
Let me see, is that what I
We
got?
went from 6 plus 5.
Okay, I made a mistake or you made a mistake. I did not get it.
Negative 3, 8, 5,
Negative
7. I got
1,
7.
2, 1.
I got 7.
How'd you find out?
So negative 3 plus 8 plus 2. Yeah, I think that is 7.
Mental math.
Alright. Alright,
Chin,
at least you did it.
That's your
chin.
Alright, he's got a bottom row.
12.
Blake,
7, 6,
7,
17.
6, 17.
Good.
That's what I got too.
Good.
Anybody have a question about any of those numbers? I know you just keep hoping I'm gonna shut up, I'm not shutting
You
up.
can't do the next one.
CV, we'll see that one. CVI,
Can't do
can we multiply C times V?
No.
No,
It's
because
3
it's
by
a
2.
2 by 3 and a 2 by 2, and that cannot be done. So problem I is a cannot do. What does it mean when we put the little subscript at the top? And that subscript can be uppercase or lowercase. So it can be either one. That is the notation for the transpose. And when we transpose, we take matrix C and row 1 becomes column 1. In other words, we kind of flip it on its side. So instead of having negative 1, 2, 1 across the top, we have negative 1, 2, 1 first, and then we have 3, 0, 4. That's what it means to be a transpose. Can we do D minus A? Yeah, because the rule for subtraction is the same as the rule for addition. They have to be the same size. Now we're subtracting, so just be careful. Negative 1 minus 1. Negative 2. 5 minus negative 1.
6.
6 minus 2.
4.
7 minus 3.
4.
There's your answer. Easy as that. Easy as that. Alright, I know I said I wasn't gonna stop, but we don't have time to do number 4. So we will start here on Monday. On Monday, we will review, we'll finish this review.
890